Yeah, so I'm going to talk about SpikeGLX, which is the second major GUI software that you can use for Neuropixels. Um, I want to note that today, that this very day is the 11th anniversary of my adoption of the original SpikeGL, which was a NI only software for doing data acquisition, and that was written by a software developer named Kalen Kulianu. And when I was starting this project to do Neuropixels, I surveyed a number of options for how to start getting into this, and did I want to base what I was doing off of something else? And this has provided a fantastic starting point for me. So I want to give a heartfelt thank you to Kalen. In this talk, I'm not going to go over all the features of SpikeGLX because I've done that in prior years. And instead, I'm going to point to where you can find introductory materials on the web. And in this talk, instead, I'm just going to point to where to find things, give some orientation, uh, and show some new things that we've put in recently, and talk about a particular area that I think more people should be aware of, which is how to effectively select sites on your probe. So SpikeGLX is more than just a single program. It's part of an ecosystem. There's a bunch of other programs that I also work on that go together with this. In particular, we have a bunch of scripting languages. So OpenEFIS can be expanded by plugins, and we offer you a scripting language where you can write your own extensions to SpikeGLX using your favorite language. And I'll talk more about that a little bit later. Um, these two components, CatGT and T prime, work together with the built-in uh, square wave generation that the modules that the IMEC hardware have in order to do synchronization. And that's something, just to be clear, that happens in post-processing with SpikeGLX. And it actually works very well. I know a lot of people have this feeling that Arduino, it has to have an Arduino and so on. But really, hundreds of people are using SpikeGLX to do synchronization in our standard way with extreme precision and successfully. So there are options about how you do this. Other parts of the ecosystem here are tools basically for rolling your own analysis, eliminating artifacts, doing things like that. Where do you get this stuff? Well, it's all together on our download site. Here's a link to that. I want to urge people to always get the latest versions of software so they get the benefits of bug fixing and the newest features. And also it helps me work with them to debug any problems, since basically being all on the same page. Also on the website, there are pages to find manuals and documentation of all kinds. In particular, I'm adding now getting started tutorials. I have a bunch of them up there, but I'm going to be adding more. Um, so here's the help section of this website. There's many categories of help. um, Sorry about my voice. It's going out from practicing too much. Um, I want to remind everyone who's doing this to join the Slack channel. This is the primary place where everybody should be asking any questions that they have. By doing this on the Slack channel, the entire community benefits from other people's experience, and everyone can learn together. All the help documents, I'm going over them, refreshing them, updating them, improving them. In particular, the difficult to read CatGT document is better organized and has a table of contents. I want to point out a bunch of quick starts for getting started with PXI if you're new to that, or OneBox. Here's one for Quadbase. It's absolutely essential for people starting to use Quadbase to read this document, because there are certain new things you need to know about. And I'll just name one in particular, which is with Quadbase, you must plug in things into your PXI chassis before you power the chassis on. So that's just one example of something that's brand new with quad base, and there are some other things you really need to familiarize yourself with that. Okay, so I'm going to talk about a couple of new features so that you're not too surprised. This is for existing SpikeGLX users. It used to be that when you wanted to change the vertical scale in your graphs, you selected a graph, you change the scale, and the next thing you have to do is click this green button to propagate that change to all the graphs, which is a huge waste of time. And I don't know why we were living with this for a decade, but I finally killed this feature. So now when you update your settings, they update in all graphs right away. It's a lot better. For people using audio, thank you to Gabriel Stein for forcing me to make this feature called, I call it click and play, where when you turn this on and you browse through your channels, either on the graphs or the Shank viewer, it plays right away instead of having to go to the audio dialog and select that. Another brand new feature suite is making a waveform output for stimulation. So optoprobes are coming, and we're going to need to do opto stimulation waveforms. This can also be used for electrical stimulation or any other kind of stim. So it's got two parts. There's something called a wave planner dialog. And this uses a very simple programming language where you can use four simple commands for a constant voltage, a linearly ramping voltage, a sine wave, and loops. And using these simple commands, you can create very complex waveforms. And then you can save those. They're called wave plans. You can load and play these via the scripting languages, and these can be played out of one box or NI output devices. Since I'm talking about scripting, I'll go into this a tiny bit. So the scripting languages, there are 5 different languages. They all cover the same things. What you can do with these are get and set parameters. You can stop and start runs. You can fetch data in real time and do closed loop experiments. Build your own new features or integrate SpikeGLX into a larger workflow in your lab. So they're very versatile. I just want to point out for the people who like to do Python, which is probably one of the largest communities, that when you go to my website to get the Python scripting language, you're actually going to get the C++ the SDK, Software Development Kit. These other languages, C++, C, C#, Python, are all sort of wrappers around a C++ engine. So they all come together when you get the C++ one, but the MATLAB is a separate one. Other new things. So I've been improving our survey mode. By the way, survey mode, that's a function, as Josh was pointing out, to find activity everywhere on your probe for selecting what sites. That's something we've had now for maybe 6 years. Anyway, we're improving the signal to noise in this function by making sure to put bigger margins around the places where the hardware is making transitions. For example, the start of a run, you have to wait for amplifiers to settle. And when you go from bank to survey activity on the probe, you have to transition the hardware to new settings and it has to settle again. So we're improving the margins around these regions, staying more clear so we get better signal. In the offline Shank viewers, they would always apply a global CAR, which if you have a probe that's partially in the brain, partially in buffer, that's going to mix, it's going to basically pollute your neural data. So what you can do now is you can turn off this feature so that you can see the boundary much more clearly. And seeing the boundary, you can then set a dividing line between brain and buffer so that when you turn this back on, it will work better. Also on the Shank viewer, there's an export function. So any heat map that you see, you can output that as a text file with coordinates and values from your heat map. Something new that we're doing with errors. So we've been recording forever with Neuropixels these error flags, which signal bad conditions happening deep down in the probe hardware. These are recorded in the metadata. We're doing some new notifications, so you're more aware of the fact that errors might be happening. So three things happen now. If these errors are happening, then we will automatically open the metrics window, so you see this in real time, that these errors are happening. You're alerted to this. Also, if you open up a run that has errors recorded in the metadata with either the offline file viewer or CatchET post processor, then it will look for these errors, and if present, it'll make entries in the log. So you're alerted to this. When these errors happen, it's been a long time question, does this cause missing samples? And they can, they don't always, and it's not in a simple one-to-one way, but we're now uh, tracking the fact of missing samples by watching the timestamps on the samples that come from the hardware. And when we see runs of missing samples, we're doing two things. We are inserting runs of zeros into the software to make up for missing samples, and this keeps alignment correct among the different data streams that you're recording. And we also tabulate the fact of inserted zeros in files that get created at the top level of your data directory. Also, going forward, IMEC wants some freedom to do a little bit different stuff with different kinds of hardware under the hood. So this is something you don't really have to worry about, but there might be more references to this as we go forward, especially as Opto and NXT come out, that there's a little bit of differences in the hardware. And so hardware is going to get labeled by something that I'm calling tech. And tech comes in three flavors. There's the old stuff, 1.0, 2.0, things that are similar to that as standard. Quad base has a little bit different needs in some cases. And then there's Opto and NXT with that, which have some specialized things. So there are these flavors of tech. So base stations, firmware, head stages, probes, they all actually have slight differences. So a tech label, but SpikeGLX is being designed to watch this for you, make sure that you're plugging things together and using components that are compatible, most especially in getting firmware installed on your modules. And when you detect to start a run, we look at the tech of everything, make sure that checks out. Okay, so I'm running long as I always do, so I'm going to switch now to selecting sites. The most important thing I want to talk about in selecting sites is how to select sites effectively. So first of all, to get the editor to select sites on your probe, it's here on the IMEC tab of the configuration dialog. You double click here under IMRO and you pull up this editor. The editor basically has a bunch of options for how to size boxes to encircle sites. And so you make a box of a certain size, and then you can click and lay down boxes. You can change the size of the boxes and click and click and click. And you see there's a lot of versatility in how you can pepper the probe with boxes. So there's much more you can do than just the first bank on the probe or the second bank on the probe. You can have very fine-grained site selection capabilities. But the important thing is how are you going to pick boxes in a sensible way? The most important thing really to know about this editor is it has a save button where you can save out an IMRO file, and it has a load button. So you can load a file that you made before. And the thing that you want to do is you want to create IMRO tables when you have some context to look at. Basically heat maps on the probe. So how can we do that? So here are some ways. So when you're running a run, you can open up the Shank viewer at any time with this button here. The Shank viewer has a view tab and an edit tab. The view tab, you control the heat map. The edit tab, is this thing where you can make boxes. So for example, you can click new boxes even after you start the run. You can try different places on the probe, hit apply, see what kind of activity is there. You can do this repeatedly, and you can save files from here. So that's one thing you can do. That's not very efficient, really. If you're getting the anatomy fed in from Pinpoint, I'm sorry, I'm going really long here. Or Trajectory Explorer, that shows up on your Shank viewer. And so you'll see the annotated regions. You can apply color from those regions to your graphs or to the shank, and this gives you some more context about what parts of the probe are interesting. And we have our own survey mode. To do that, it's very simple. On the IM tab, you click a box and how long you want to survey each bank. And then we collect data from each bank until the entire probe is covered. That's all collected in one file that you then can open up with the offline file viewer to review the results. I want to mention here something you can do that's critical while you're doing this survey is that you can be stimulating the animal or recording animal behavior and using TTL signals to record when interesting things are happening as you're doing the survey. So now when you open up the survey in the offline file viewer, you can scroll through it in time and you can see coordination between neural activity and when behavioral things are happening or stimulation things are happening. That's one way that you can look at the data on the probe. And another way is you can integrate across the entire survey through time and colorize the entire probe, find activity this way using these controls. Okay, so that's really the talk. New things I'm doing. I have a list of things, ways that I'm going to enhance ways to look at activity on the probe for better site selection, but I'm going to stop here.